Hello, and welcome to today's lesson. We've got Circles and Polygons, Unit 3, Lesson 3. And in today's lesson, we're going to learn to write the equation for a perpendicular bisector and find the circumcenter of a triangle. And the circumcenter is where the perpendicular bisectors intersect. So now, just some quick review from the previous lessons. What point of concurrency for the three perpendicular bisectors of a triangle? And it's the circumcenter. Okay, this point of concurrency is equidistant from all three vertices. So that's why we're looking at some of these. We're looking at these ones are critical ones for working with triangles, working with either circumscribed circles or inscribed circles because they're so valuable in different areas. What point of concurrency is for the three angle bisectors of a triangle? And that is the incenter. Okay, why is the incenter important? Is its equal distance from all three sides. Okay, or an inscribed circle. Okay, so now, last one we have, what point of concurrency is for the three altitudes of a triangle, and that is the orthocenter. Okay, this point of concurrency could be inside or outside based on the type of triangle. And notice, for a right triangle, the orthocenter is actually on the triangle, and it is one of the vertices. Okay, last piece we have here, what point of concurrency is for the three medians of a triangle, centroid. How do we find this? We average the x's, average the y's. So now, some algebra review here. Things that we're going to have to do in this lesson is we're going to have to find the midpoint of two values, and that's just the average of the x's, average of the y's gives us the midpoint. Okay, we're going to have to find a slope. Slope is the change in y over the change in x. It could be y2 minus y1, x2 minus x1, okay, or we could have those flipped around. The important part is that you subtract, and you subtract y's on top and the corresponding x's on the bottom. And we have two forms for our equations of the line. We've got slope intercept and point slope. Point slope works a little bit quicker because we're already going to have a point and we'll have the slope. Slope intercept is something that we will have to get to in order to find points of intersection. So now, when we're looking at the situation, we've got this triangle RES with the vertices R, E, and S. We want to find the equation of the perpendicular bisector of RE. So what we have to do is we're going to have to find the midpoint of RE. That's the bisector. Okay, so that's our first step. Finding the midpoint of RE, and then we're going to have to find the slope, and then find the perpendicular of the slope, and then we can write the equation of the bisector. Okay, so now the midpoint of RE, we have 0 plus 4 divided by 2. So that gives us an x value of 2. Remember your parentheses. 0 minus 6 divided by 2, okay, gives us a negative 3. So now we have the midpoint of that value. Okay, perpendicular bisector. Okay, so now we know the point that this line has to go through. So when we're building our equation, it has to go through the midpoint, and it has to be perpendicular to this line. So when we're looking at our slope, we're going to find the slope m of RE so we can find the perpendicular to it. Okay, so our slope, change in y, negative 6 minus 0 over the change in x, 4 minus 0. Okay, we have a slope of negative 6 over 4, but we don't want to leave it in that terms. We want to simplify it as much as possible. Don't go to decimal form. Okay, we want our slope in a simplified fraction form. So we have a slope of negative 3 over 2. Now, next thing we need is our perpendicular slope. And remember what it means to be perpendicular. Perpendicular is an opposite reciprocal. Opposite means we change the sign, so it's not going to be negative, it's going to be positive. And reciprocal tells us that we have to flip the fraction. Okay, so we flip the fraction. Okay, now we're here in this situation. Now we're going to build the equation. The equation needs the slope of the perpendicular and the midpoint line. Okay, we don't want to use the original points anymore. Those were there for the slope, but it's not the points that we would use for our perpendicular bisector. So we have y minus our y value, which is a negative 3, plus or equals the slope of 2/3. Man, having some writing problems here. Times x minus the x value. Okay, so now this is our point slope form equation. We can stop here in this situation. But if you're ever going to set two lines equal to each other, we have to get this into slope-intercept. So how can we get this into slope-intercept? The first thing that we would have to do is simplify and distribute. So now we've got 2/3 x minus 4/3. Okay, so I've simplified the left, distributed on the right, and now we need to move the 3 to the other side by subtracting 3 from both sides. And we have y equals 2/3 x, and we have 4/3 minus 3. Okay, remember 3 is actually 9/3 as a fraction. So we have a minus and minus, so they're going to build together to give us a minus 13/3. Okay, it's always tough to deal with fractions, but we want to look at those and deal with those at times to help us as we work through our material. All right, so now find the coordinates of the circumcenter. So what we've done now, okay, remember the circumcenter is where the two perpendiculars, or all three perpendiculars, bisect each other. So we only need two of the three lines to make this happen. Notice what we've done here in this example. We've gone through all of the work to get you to this spot, the y equals equation. We've got the two y equals equations here. Now, if these two lines intersect at the same spot, then we know that this is a one spot where the y1 equals the y2, and this is just a substitution situation. So we have a 0.5x plus 1, that's y1, equals y2 negative 0.5x plus 4. And now we have to move the variables to each side, so I'm going to add a 0.5x to both sides. We do that, we get 1x plus 1 equals 4, and then we have to subtract 1 from both sides, and we get x equals 3. So we have the x value, and now we just need to plug it into either of the equations. I would suggest plugging it into both. Time-wise, though, I'm just going to plug it into one. Y equals 0.5, or 1/2, times 3 plus 1. Okay, now, why can we use decimal values here when I've said you can't use decimal values in other situations? The reason for that is it is a perfect decimal of a 0.5. versus a rounded or estimated decimal of a 0.33 or a 0.333. So we have 1/2 times 3, we've got 3/2 plus 1, or 1.5 plus 1. Okay, so if you want to use decimal form here, you can, and that's the y value. Now, we can't stop there. Remember, we need the coordinate points of the circumcenter, so I need to put the x and y together to make it a coordinate value for that point. Okay, that concludes our lesson for today. Good luck on the homework. Remember to look back at some of those steps there, especially solving for y, getting y by itself, and we will see you soon.